Oh, hi there. Thanks so much for showing up for your math learning. It's Tutor Grant, and it's not often I get called out in the community for not keeping my commitments. So when that happens, I like to very quickly redress the error. I mentioned like months ago that I had a cool way of finding Pythagorean triples. Okay, let's go with some just very straightforward algebra, and I'll show you my method for finding Pythagorean triples. We're going to start with our triangle here. And we know that if that's right angled, then a squared plus b squared is c squared. Or in other words, b squared is equal to c squared minus a squared. And if you know your differences of squares, you'll know that that's always equal to c plus a multiplied by c minus a. Okay, and that's all trivials, just algebraic ping pong, just going back and forth. But now we're going to do something. We're going to assume a relationship between C and A. Okay, so we're going to do things like let's say C, which is the longest side in the triangle, is slightly longer than A. We got A plus 1. Okay, and then we have, so this is our assumption. Okay, and it's going to allow us to find the Pythagorean triples where C is 1 longer than A. So then we get B squared equals a plus 1 plus a, because that's c, and then a plus 1 minus a. All right, a plus 1 minus a is just 1, and a plus 1 plus a is 2a plus 1. Okay, so then we see that we can create as many of these as we like with this little mini formula. Okay, so that is to say b must be a number that when squared is odd, because 2a is always even, okay? And then we can find a by just taking b squared and doing that. So we can do things like say, let's let b equal 3. Then you have 9 equals, let me do it over here. Just erase my crazy arrows. I gotta reduce the number of arrows I draw. I have like arrow addiction. So let's say b equals 3. We're going to just decide that, and then we'll find the Pythagorean triple that makes it true. So that would be 9, that's 3 squared, is equal to 2 times some number plus 1. Well, that solves to be 4 equals a, right? And then we say, well, what did we say up here? We said c was a plus 1, so that makes c equal 5. Oh, we just found the basic 3, 4, 5 triangle with this little bit of algebra. Let's see if we can try a bigger odd square. Let's say b is something different. All right, we're going to make b an odd number that you like, 13. Okay, so that means b squared is 169 equals 2a plus 1. That means, gosh, a equals, well, half of 168. That is a number. Is it 84? I believe it's 84. Okay, 84 times 2 is indeed 168. Good. So then that means C equals 85, because we decided up here that A would be 1 more than 1. 85, and then A is 84, and B is 13. Let's draw that triangle. It's really long. It's right angled here. This is 13. This is 84. And this is 85. Let's see if it's true. Clear. 13 squared plus 84 squared equals this number. We're going to take its square root, and it's 85. Of course, we knew it would be 85. Or if you didn't know, or you were doubting me, how dare you doubt me? Okay, no, that's fine. You absolutely should doubt me. This is me trying to be funny, trying very, very hard. Okay, so that's if A is 1 bigger. But what if we said something like, well, we're actually interested in triangles where we're a little bit further apart, like C over here, A over here, and C equals a plus 2, let's say, and we still have b over there. We're still in the same situation. B squared equals c plus a multiplied by c minus a. That's a feature of all of these triangles, all right? But now we just feed it this piece of information, and we have b squared equals a plus 2, that's c, plus a, multiplied by a plus 2 minus a. And then you'll find that we get this is going to be b squared is equal to 2a plus 2 multiplied by 2. Okay, or in other words, b squared equals 4a plus 4. Now we can notice that, well, b squared better be an even number because its square has to be divisible by 4. And every even number has a square that's divisible by 4. That's not hard to show. And so now let's just try one, okay? Let's try 8, because I happen to know 8 is moderately interesting. If you try 6 or 4, you will get Pythagorean triangles, but they're all going to be scaled up versions of the 3, 4, 5. If you let b be 8 here, just any even number will do, and you will find a Pythagorean triple with this property. Okay, so then we have 64 is equal to 4a plus 4, and this solves to give a is equal to 15. Cool. And up here we said, well, we're interested in triangles where this is 2 bigger. And of course, we found one. We found this triangle, which is 8 and 15 and 17. Another base Pythagorean triple. Cool, right? Right? It's super cool. I think it's cool. Let's try something else, just to make this a slightly longer video. But you can try different relationships. Let's try 10, where there's a gap of 10 for fun. Okay, so we've got this triangle here, where c is a great deal longer. So c equals a plus 10. Okay, it's way longer than a, and there's b over there. We're still in this situation that b squared equals c squared minus a squared, or in other words, b squared is equal to c plus a times c minus a, and we know that c equals a plus 10. So we are here b squared equals 2a plus 10 multiplied by 10. All right, so now we have b squared equals 20a plus 100. All right, so now we have to find squares of this form, okay? Squares that will solve that equation. All right, so they have to be number like 120, not a square, 140, not a square, 160, 180, 400, all right? So 400 is one that will work. So let's go ahead. It has to have a factor 10, this square, and so it's going to be square numbers that have a 10 in them. So you can let b be 20. b equals 20, and then you have here 400 equals 20 times a plus 100. That makes a 15, and this is, again, kind of uninteresting. Because, wait, yeah, it's uninteresting because a is 15. And why do I say it's uninteresting? Because oftentimes when you do this trick, you're going to find things that you already knew. Like you already knew 15, 20, 25 was a Pythagorean triple, because that's just the 3, 4, 5 triangle multiplied by 5 to make it bigger. Okay. So this isn't a method for finding exclusively Pythagorean triples, but if you keep going and keep finding, like, you know, you go ahead and you put in 900 there, maybe you find something more interesting. Maybe you put 1600, you know, these types of things. Maybe there are other squares that, you know, don't end, yeah, anyway. And then play around with that and find what you find. And have fun. Have fun finding your own Pythagorean triples. Now you don't need to Google lists online, although you can still Google lists online. If you spend your time Googling Pythagorean triples, you're probably still on the math team, okay? That's like, it's still a good activity. Like if I get like a number like 991 and I'm like, is that prime? I could do the sieve of Veracines myself, but time is a limited resource and I'd rather just know. So I'll just Google it. So yeah, have fun and let me know if you have any insights or find any cool Pythagorean triples doing this yourself. Bye.